Hello, my name is Cosmo. Today I'll talk about my final project, Income Inequality and Housing, Predicting Housing Prices with Linear Regression. The task of this project is to train linear regression models to predict the housing prices with various features. So as I started my journey, I quickly noticed that there's a conflict in my proposal and machine learning models, leading to future challenges, because that my initial research goal is to establish relationships between two variables, while machine learning focuses more on predicting the values of dependent variables with the existing data. I need to expand my data set, or otherwise it will be too small and too simple for machine learning models. And I did so by adding more features related to the existing features, such as adding student loan rates to student loan or unemployment rates to income inequality. All the data I collected were publicly available on the internet, and I pieced them together into one Excel file. Due to lacking in some historical data, especially in student loans, my data set is limited to a very small size. So I have a total of 18 features, with each of them having 56 rows. That gives me a total of 36 data points in 36 data points, and I filled in some of the missing values by using a linear regression trained with the existing values in that column. So after exploring all the models, here are some of the reasons why I do not use these models. For decision trees and random forests, either classifier or regressor, I do not use them because they conflict with the purpose of this task, which is to establish a linear relationship. And for logistic regression, it's not the best choice to show linear relationship in this project. As for logistic regression, deep learning models, they are too complex for my small data set, and they overfitted the training data. So I believe they are not the best choice for my data set. So here are the models I would adapt and explore in my project, which is the various linear regression models. So after I split my data set into training and testing sets, my linear regression models perform with a high accuracy. However, that noticing the training data, the testing data set with as many features as rows, it might be an indication for the risk of overfitting. As for after polynomial transformation, despite the model gives me a higher accuracy, I noticed that I'm having way more features than rows, and this is a huge risk of overfitting. Then I tested ridge regression, which the accuracy is slightly lower. And as for lasso regression, it has the highest accuracy. However, that the ridge and lasso regressions were built on the polynomial training sets, and therefore the high risk of overfitting existed. So the lessons I've learned from this project is that the logic for data collection for machine learning models is different from traditional social science papers. And although that more complicated models, such as deep learning models, could be more accurate in producing results, for some data sets, especially those small and simple, simpler models works better. And I've learned a technique which is it's wasteful to have only one row of data for certain features. So, and I could further expand my data set by breaking down national data into different states and if even different cities to increase the size.